All right, welcome to the third session of today, the next generation of data historian, leveraging time series for operational insights, and the moderator, Hamish Mackenzie. Hamish, the floor is yours.
Thank you very much, Lucian. So hello, everybody. Good morning, good afternoon, good evening, maybe where you are in the world. My name is Hamish Mackenzie, and thank you for joining us for today's session on data historians. First off, it'd be great if you could just pop into the chat who you are, where you are. It's always nice to get a feel for who's joining us. And while you do that and get settled in, maybe grab a coffee, whatever, there are a few bits of housekeeping I just need to get through. The session's going to last just shy of an hour. I'll be introducing the topic and our guest speaker today. And obviously, we'll be getting a lot of valuable insight from him. But we will leave plenty of time at the end for questions from the most important people in the room, and that is, of course, you, our audience. I've got one request. Please put your questions in the Q&A function of the tool and not in the chat. It simply makes it a lot easier for me to find them and see what questions are coming in. And it also makes it more likely that your question will get answered. So use the Q&A tool. It makes my life easier, and I'm always a fan of that. So yeah, and don't feel you need to wait till the end either. Just as they come to you, get your questions in there, and we'll get to as many of them as we can at the end. Before we dive in, as I'm sure most of you are aware, IIoT World runs quite a few of these events throughout the year, and I just want to give you a quick heads up on a couple that are coming up. On May 22nd, we have Manufacturing Day. July 24th, we have Smart Buildings Day. And September 10th, we have Sustainability and AI Day. There are a couple more after that, but those will keep you going for the time being, I think. So go to the IoT website, check all the details out, get your registration in if registration is already open. And with that, time to focus on today's session. So data historians play a crucial role in the dynamic industrial IoT ecosystem. I think we all know that. We've got countless devices and systems generating continuous data streams, and that all needs to be managed. But this whole process can be complex, expensive, limited in terms of the ecosystems, APIs, and customization requirements that people have. And so during this session, what we're going to explore is how to modernize your data historian by harnessing the capabilities of a time series database, or TSDB for short. Explore the essential factors to consider when choosing between a TSDB and a data historian, and gain some valuable insights into the real-life architectures being implemented by the early adopters in this space at the moment. And we're also going to look at some innovative approaches that can really revolutionize your industrial operations by using these time series approach. And I'd like to introduce now our very special guest that we have to take us through this. This is Mike Devi, who's a solution architect at Influx Data. Mike has over 15 years of experience in systems admin. And prior to his current role, he worked at Qualys as a production operations engineer, supporting data center server infrastructure and large enterprise customer deployments. With Influx Data, he engages daily with a wide range of customers. He says no one is too big or too small for him to be able to help. And he helps them better understand how to use the time series database platform to help them streamline operations and help to solve the challenges that everybody is facing now in this data-centric, data-driven world. And he says that oftentimes he's putting himself into the shoes of developers and users in order to help them out of some sticky situations. So he's almost like a time series database superhero, if you want to look at it like that. I'm not sure he sees himself like that, but that's how we can think of him, I think. So thank you very much for joining us, Mike. I'll come to you in a second. Very quickly, a few words about me. I'm a former IDC analyst. I've been running my consulting, advisory, and coaching practice here in Munich since 2006. And I work with CEOs, founders, other senior executives in technology companies in the US, in Europe, helping them improve their growth efficiency. That includes also things like helping them integrate generative AI into their workflows. And I also help the founders and leaders within those organizations help focus on the things they really should be focused on, which is strategy, evangelizing about the company and the products, and helping removing them from the kind of day-to-day nitty-gritty that it's very easy to get bogged down in. So that's what I do. If you'd like to know more about what I do, please look me up on LinkedIn. I think I'm the only Hamish Mackenzie in Munich, so it shouldn't be too difficult to find me on there. Very quick reminder, please get your questions in throughout the session and use the Q&A tool to do that, okay? And that will give you the best chance of getting your question answered. And with all that said, I think it's now time to hand over to the expert. So Mike, the floor is yours.
Thank you very much, Hamish. And thank you, everyone, for joining. Hopefully, today's session will be informative. Mike Devi. I'm based here out of San Jose, California, and just south of Influx Data headquarters in San Francisco. I've been here for almost 5 years, and I have a deep passion for technology, for databases in general. I love getting my hands on things and really getting a deep understanding. So I work as in the pre-sale side as a solutions engineer and solution architect. So that leads me to a lot of exposure of how folks are solving problems. I myself have had to build a very custom solution in my past. It was a configuration management database, or CMDB for short. And the reason why that had to be built custom was there was nothing off the shelf that's available that worked exactly like the company that needed the solution. It was tracking almost 100,000 pieces of equipment physically located throughout a very large data center space. So that required custom tailoring. So that was a little bit about me. Let's talk about what we'll be. Looks like I skipped 2 slides. What we'll be doing today. The goals of today really are to understand the key differences between data historians and more general purpose time series databases. We'll discuss what are the challenges that are faced by historian customers today, why they tend to turn to Influx Data or InfluxDB or even other solutions. There's a lot to choose from. And then, of course, what are the benefits that the time series database gives you, and specifically InfluxDB. So you might find I'm wearing the t-shirt, so that's where I'm most knowledgeable, and happy to share as much as I can over my time here that I've learned. So yes, the quick agenda, we'll discuss historian versus time series database. We'll touch on the latest and greatest innovations that InfluxDB 3.0 gives us. It's the latest iteration, and we'll sort of talk about why it's different. And that kind of leads us into what are some of the integrations and the partners that we work with that interconnect with InfluxDB very well. We've been around for a long time. A lot of folks have built us as a persistence layer, and we're part of the overall stack and solutions. And of course, it wouldn't be interesting if we didn't give you some real life customer examples. So we have some nice little diagrams and stories that go with that. So hopefully from all of that, there will be some questions and answers that we can get through. So let's start with what is a data historian? Essentially, it's a specialized database for industrial settings. These are typically deployed on premise due to security constraints. Really stringent security postures are required when we're dealing with OT restrictions. We want to make sure that the data is going one way or it's not being exfiltrated. So it's a really tightly designed system. Time is of the essence, of course, and latency is typically something that can make or break the operational side of the house. So manufacturing, as we know, heavily relies on high frequency timestamp data in order to be able to go back and understand where something may have broken down so that we can fix that. So data historians have been around for a very long time, and they tend to be what we consider the buy side of the house. So when considering build versus buy, data historians are geared more towards the buyer profile, where you kind of just buy the solution, you drop it into place, and you configure the knobs that are available to you. So when we look on the flip side of that, we have the build kind of side. And that gives us really the cloud as your playground, if you will. And of course, the cloud providers, they have their own solutions. They're built a lot of times on existing either open source or even proprietary technologies. And of course, have extensions into having ability to deploy on-premise components. So again, adhering to the security posture requirements. VPCs, networking connectivity can be achieved to, again, meet some of these requirements. But a lot of times we're deployed into air-gapped environments, so there's really no cloud connectivity. So that's really the nice thing about InfluxDB is the versatility, the flexibility. We have kind of a different flavor that can fit what kind of profile that you need. And we actually play very well with all of these kind of providers. So whether it's cloud or on-premise, a general purpose time series database, at the end of the road, it's really about storing any piece of data with a timestamp. So let's talk a little bit about the pros of the data historian. So these are really domain-specific functionality, right? They're built from the ground up for industrial and manufacturing environments. This is something that has been matured over a long time. They have been around for a very long time. They tend to sometimes, well, I'm not trying to skip to the next slide, but they have been around so long, and oftentimes it creates kind of a restrictive deployment pattern. But all of this is achieved because they are very good at what they do. They are extremely well integrated into OT control systems and the typical standards that are around. And it's really an end-to-end solution. So a mature data historian has really rich built-in functionality to connect really from A to Z, and they've been doing it for a long time. So they can't be perfect, nothing is. So what are some of the cons? It tends to be that they've been around for so long, it's a very rigid technology. So you kind of don't want to get left behind. The upgrades may not be as fast. Perhaps some of the newer technologies will take time to trickle down and to actually get implemented. So yeah, they tend to become kind of that walled garden of proprietary technology. And that tends to slow down, as we know, the innovation, the ability to grow. So keeping up with newer technologies it means that it's a little bit more difficult when you have this proprietary technology that kind of locks you in. What it also tends to do is to create these closed systems with organizational silos, and you have multiple data sources that don't really talk to one another. And this is in some cases by design, but to get kind of that superset of data, it's difficult to get that holistic view, that single pane of glass. So that's another problem that data historians tend to create. We've kind of solved that. We have some solutions around that with our approach. Another thing is a vendor lock-in. So once you have a very mature end-to-end solution that's put in, it can be pretty difficult to rip out. It will disrupt operations. It's not really what you want to do when everything is humming along. You don't want to disrupt when something's there, especially from a cost efficiency standpoint. They can tend to get quite expensive. One example of that is a lot of these folks, they have pricing models where you have to pay per tag, which means that if you have a piece of decommissioned equipment and that's still has a tag footprint in the system, you're actually paying for that decommissioned hardware in addition to the new one. So that tends to be not very attractive use of our data usage. So as we look at time series databases, what are the pros of that? So they tend to be a lot of times cloud native. They're modern, right? These are open technologies. We like to call ourselves. So we're not a data roach motel where data goes in, it never comes out. So we are an extremely open platform, and we're of course kind of that goes in line with the Industry 4.0 transition in order to achieve application versatility, enable developers to be agile in adopting new technologies and supporting new capabilities, and of course. That is how we are able to achieve integrations into ecosystems and APIs and all the connectors and protocols and tools that go with that, of course. So with the mass amounts of data that we accumulate, we must be able to derive some kind of a useful information from that. And we can only get the data massaged with as good as the tools that we have. So a flexible query language tends to be something that you get with a time series database. We have something that we call InfluxQL, which has been around forever, as long as InfluxDB has. But in the newer version of 3.0, we've actually introduced the native SQL, if you will, the Postgres dialect of SQL. So that enables users to use what they know, what they've been using for decades, and to use that with a time series database platform. It's very powerful. The real main pro of a time series database is that we excel in real-time processing. A lot of times we refer to that as the leading edge of data. You can think of that in the last 5, 10, 15 minutes, because if something happens in the manufacturing space that something is wrong, the timing is off, the vibration sensor is perhaps vibrating more than it should, and there's a breakdown occurring, we don't need to know about that tomorrow. We need to know about that today. So real-time processing is key in order for a time series database to actually be effective and provide value. But providing value can also be something that's a cost-efficient, scalable, and commercial model. So these tend to be kind of usage-based. So you pay for either the compute or the usage that you're subscribing for. And of course, if we were inefficient in what we did, that would not be very attractive. So scalability of the system and storage efficiency are especially some of the new themes of the 3.0 platform. So we're able to achieve much bigger scale, newer technologies, Kubernetes, I'll just throw that out there. It's a big buzzword everyone loves. And object storage. So just reducing what you pay for the data that you're storing on the medium that you're storing it in. So again, nothing is perfect. But just before we get there, we support massive scale. 3.0 gives us unlimited cardinality. I could talk a little bit about how we've achieved that, but it's really more about hybrid deployments. Again, one of my favorite things about Influx, more than one way to solve the problem. So having an edge solution that complements and marries up to an on-premise and or a cloud-based implementation. This can enable all lines of business, from the sort of boots on the ground to the management and sort of the forecasting layers of the organizations. A hybrid deployment can give everyone what they need without putting things at risk. And speaking to that hybrid deployment capability, edge data replication is kind of another topic that we're talking more about. We're enabling, we're building into the solution. These are store forward capabilities. So you can think of it as you have a lightweight component that's somewhere in an area of connectivity that is not always very well sustained. The data is stored locally until it can be replicated to a central store. And at the edge, you still have the compute capability to create alerts, and actionable sort of things can occur, so that the edge is also living and breathing and providing value, not just rolling data into a central store that then does the processing. There's a good list of pros here. We have a thing that we like to call time to awesome. And I would say part of that is the schema on write. So you don't have to spend time really defining the data structure. We have line protocol. It's a CSV-like format, which instantiates your tables, your fields, your indexes, if you will, the tags. So you send the data into the system. You can expand the schema on write at will. Of course, it is a double-edged sword. So if you have uncontrolled systems that are just sending various data types, these pros can quickly turn into cons. But in a properly controlled system, schema on write is a fantastic capability to have. And of course, kind of coming back to the cost efficiencies, hot and cold storage tiers solve both the problem of cost efficiency, but also performance, so that you can have really fast queries for that critical leading edge data, but also have the cold storage for that required, I have to store this data forever at high resolution. It can't be aggregated, downsampled, anything like that. So that's kind of the additional pros of InfluxDB. Really, we're an open source company. So Influx Data is the company behind InfluxDB. But we have a vast community, almost 1 million deployments of open source, network integrations with a large network of partners. And every day it seems like somebody's building something really cool with InfluxDB. So it's always nice to learn. The list goes on, but we'll kind of talk more about it. Let's talk a little bit about what are the bad things about it. It's not domain specific, so it's really general purpose. This is the build side of the house. So there's going to be significantly more effort that goes into building something custom. But at the end of the day, you get something that's a lot more tailor-made, that's much more sort of suited to exactly how the business operates. So the effort and the learning curve tend to be detractors to getting started, of course. But it really depends on the level of pain, the level of customizability that's looking to be achieved. And finally, you do require, sort of the ecosystem to fulfill all the industry-specific capabilities and create that end-to-end solution yourself. So when the data historian is just kind of that drop-in solution can be a significant price tag, the time series database approach tends to be you choose the components that you feel are best suited for you. You're not locked in, and you have the ability to adapt and sort of shift and build as you go. So a lot more flexibility, but at the cost of having to work with it all. So if we look at the future of industrial data, we have a lot of keywords that are thrown at us. Of course, IoT, cloud, edge. Right? We have 5G networking that kind of connects all these components that sit in disparate in places that really have bad connectivity, whether it's floating in the ocean, whether it's sitting in a mine somewhere. We want to then include all these AI, ML, not forget about security. We want to be able to do things that are in real life, but in the digital sense, and derive all these real-time analytics from that. So, of course, I won't read all these words, but all of these left column buzzwords are really to enable what the operational efficiencies, what the business requirements are in order to be efficient in how that business is going to sustain operations and likely want to do it profitably in doing so. So really, cost controls at the end of the day is kind of the key ingredient to why all of the other things are even talked about. So here's kind of a nice little chart where the operational efficiency really shows us that we want predictive maintenance, which is why I mentioned that little vibration sensor. It's kind of like the Achilles heel can take down even the strongest of us. So we want to stay ahead of things, not experience failures of multi-million-dollar machines when they're out in the site. We'd rather perform a much cheaper maintenance and repair when we can bring them in for preventative maintenance. So all of this takes data, and that's kind of the push that we're seeing. So kind of an eye chart here, but what this is really meant to discuss is data historians, they tend to have kind of those typical personas that we've been used to seeing here. So on the top left, the typical users have been the OT engineers, the folks that are implementing hands-on with all these systems. We have the architects, the project managers, right? The folks that work really, really closely with getting these systems up and running. But now we have these newer users that really want to get their hands on this data and do more with it so that they can enable and ask more of the typical users. So we're talking about the data scientists, data engineers, the business analysts. They're working with the big data problem to figure out what are those small tweaks and turns that can be made along the way. As always, increasing operational efficiencies, cost efficiencies, right? There's so much data volume. There's a lot of moving parts. So we're getting a lot more information, but really what we're trying to do with it at the end of it all is to provide better insight into how the business operates, predictability, right? That single pane of glass of all of these moving parts together, but to be able to achieve this real-time OT monitoring. So again, I won't read all of these, but with all of these different personas, challenges, business requirements, here's kind of that mapping of InfluxDB lending itself to being able to solve kind of those asks. So I'll touch on a couple of key ones here where we have my favorite, Telegraph. This is our Swiss Army knife. So if you have data somewhere, Telegraph can be configured to go and get it, whether it's from your MQTT broker, whether it's an OPC UA. It could be really as custom as you already have a script and you need some kind of a scheduler which creates that line protocol and sends the data onwards into a time series database. That's InfluxDB, that's what Telegraph is best for. It's really becoming that de facto collector agent. It's actually so great. A lot of our competitors recommend it for their solution as well. So it's our most popular software. It's open source. It does things that InfluxDB likes, like sorting and batching. It introduces jitter, right? So you can see that it's a very capable software, but it's only part of the puzzle. So I will say the biggest thing that we've been able to achieve is unlimited data cardinality. So having a single data store where you don't have to have these sort of disparate data silos because you just can't have a system large enough to house all this data. I'd like to say we've solved that problem at Influx Data. So you can send everything from your very large operational sites into one place. Of course, it still takes planning, but we can do quite a lot. Okay, so let's talk about how we've been able to do it. So InfluxDB 3.0, it's a new database, new storage engine that we've been working on for several years, and we just launched it just at the end of 2023. It forms the new core of the platform itself, and essentially, first off, it's written in Rust. And just a little fun fact, it's internally codenamed was IOX, which is the iron oxide, which is Rust. So it's a little fun fact. Why Rust? Why I bring that up is because we're typically a Golang shop. So Telegraph is written in Go. Everything else that we've done has been in Go. Rust is that thing that's pushing technology. It's we've sort of made a bet on it. It's going to be the thing that gets us to the next level of performance, security, all these things. So it's a big shift for the company. But we've been able to not only rewrite the storage engine, but also introduce why it's worthy of a 3.0 moniker. It's using Kubernetes now. So whereas the traditional deployment of our enterprise software and clustering has been kind of that monolithic deploy on bare metal or onto VMs, this is now kind of the next level of architecture where you can scale it in microservices. You can have more ingestion, more querier capabilities. It's very flexible. But yeah, 3.0, it's really meant for handling time series data at a massive scale. And why we say massive is because we've taken the bounds off of cardinality, that thing that used to always be this, you have to do the math of how many tags you're going to sustain and how long are you keeping this data. At this point, bring your tags, store your data forever. We know you want to keep it in a cheap place, so we're using object storage, which tends to be much, much less expensive than the solid state, very fast drives. That has been the recommendation. So yeah, it kind of it flips the capabilities of what was not possible before and makes things possible. So what we have here is the different versions of InfluxDB. So the cloud serverless is where it's a multi-tenant architecture. It's also at the heart of it is IOX. So you can use the SQL dialect as in addition to InfluxQL. You can build custom systems, or you can use even something like Grafana, like a lot of our folks do. So we have different flavors, as mentioned, multi-tenant, single-tenant, cloud dedicated. For the more sort of security conscious folks, there's the clustered deployment, which is effectively you run and manage, self-manage InfluxDB cluster on your premise, in your cloud, wherever you seem to need. And the kind of that, what we're looking to enable is the edge computing, the edge node, which is a very lightweight component, but part of the overall architecture, which sends its data onwards into that kind of that mothership that has everything forever from all the different sites and silos. So yeah, this is kind of the general lay of the land of the architecture that we have here. And digging into a little bit more detail, a fast time series platform with built-in analytics, what does that really mean? It means that if you're looking to store metrics, events, or those really highly volatile and variable traces, all of this can be put into one place, and it can have insight into all of this data across the board. And really performance-wise, we're looking to deliver upon that promised leading edge of data is very, very fast. So sub-second query responses are critical to sustaining OT operations there. So we want to continue to deliver great end user experiences, and of course, end users can only be as happy as management allows, and that's all going to be dependent on total cost of ownership. So if we have something amazing but it costs a lot, that's not going to keep people happy for a long time. So low cost object storage, Kubernetes orchestration to scale up when you have the need, and maybe run at a smaller scale when you don't have the need, again, to kind of bring all that cost ownership down. But really, InfluxDB starts with the developers. A lot of folks, they have kind of home projects, which then they bring to work. So time to awesome. You probably heard me say this before, but it's true. It's very fast to deploy something with Influx and get up and running with SQL, with InfluxQL. In fact, just to sign up for our service, it takes an email address, a verification email. Telegraph can be run on your local system, and you're essentially sending CPU, memory, networking metrics, and you can start graphing that effectively immediately. So, that's just the tip of the iceberg, if you will. But at the end of it all, we want to enable an open data ecosystem with the ability to put any kind of a visualization, AI, ML processing on the data store. So we want to serve that data, whether it's real time or it's historical. We want to improve overall operations and data efficiency. So just kind of the main points to drive home, because the reason we rebuilt the database core storage engine was really to allow unlimited cardinality. The pressure of how do I size and scale my system has been drastically eliminated when you don't have to worry as much about what is my uniqueness of my data, what is my cardinality. So now you can have very large deployments of extremely small sensors, tens of thousands, hundreds of thousands, millions of sensors, each ones that are contributing their own metadata, which would be unfathomable and just kind of a non-starter unless you have a really large budget, is now possible with 3.0. Can't speak more about the API integrations. We're really focusing on being that core storage engine, which is the read and write API essentially. And there's a lot of really great technology out there, and we're not trying to do everything. We want to do the database part very well, but also build that bridge to allow for those API integrations for other systems to sort of be built on top of that. So here's kind of a little look at the interoperability story, just kind of laid out. What we see is a large adoption of Apache technologies. So from Apache Parquet for the on-disk sort of persistent storage, which we put into Object Store, to Apache Arrow, which is a native in-memory columnar store for the hot data, right? You'll notice the theme columnar. That's really what we're about. Then we have Apache Data Fusion, which is enabling the use of the SQL dialect. So we're heavily contributing to the Data Fusion project. And you'll see there's a lot of Influx data sort of contributors and members that are in the GitHub repo and so on. But really what this enables is Parquet persisted in Object Store. This is where those data scientists can be brought in. They can get their hands onto this kind of read-only copy of the Parquet data. And when you have all this data, you can put any kind of a machine learning task on it. There's a lot of activities that can be sort of leveraged on top of getting actual useful information out of this this data set. So I've talked a little bit about the in-memory columnar store, but that's the Apache Arrow side of the house. So hot data typically lives for 15 minutes. But again, when we're looking at this buy versus build, and us being the build, 15 minutes can be made more or less. So a lot of customizability and configurability for really what it is that you're trying to solve. I've kind of mentioned this before already, but low-cost object store. This is very big, where customers are looking to store more data longer, forever, indefinitely, right? Whether they're required to or we're just data hoards. I know I am myself at heart. But yeah, this is the community that we're looking to help. And of course, the zero retrieval cost capability. So just having that data, being able to store it longer and in lower cost locations like glacier storage, just really effective ways of storing it. Schema on write capability. So this has not gone away. We will not make you sort of define your schema ahead of time. We have folks that are asking for like explicit schema configuration. So that's something that you can either build yourself, or we have in other product lines, not 3.0 just yet, but the ability to lock in your schema. But really, schema on write is one of our really the core capabilities, and something that a lot of folks really love. So working with newer versions of sensors that emit new data, this is a great capability that keeps the time to awesome moving forward. Edge data replication. So yeah, again, talked about this a little bit, but really it's about having that lightweight edge component, which does a very specific task, and then ultimately sends and relays its data along either in an aggregate form or a raw high resolution format for whatever kind of retention upstream that's required. Yeah, I'll be brief here. I could talk about this forever, but Telegraph, if you haven't seen it, do check it out. Extremely versatile, universal, works with our platforms as well as others. Yeah, you could do a lot with it. So it's great for the IoT use cases. It covers really the standard protocols, but also you can bring existing resources mentioned. Like if you have a script that already connects, does something really custom, you can use the Telegraph exec-d plugins to kind of use that as a wrapper to carry that work that's already been done forward. So how can we not have to build everything? So this is where the partnerships and integrations that we have are really coming into key focus here. We see a very dominant usage of Grafana. They're kind of that de facto visualization, right? When you think of like a tissue, you think Kleenex, or when you need a Band-Aid, right? These are all brand names. So we have a wonderful first-party integration for all of the query languages in Grafana. So SQL, InfluxQL, and also Flux from our 2.0 line. But in addition to that, integration within Seek, Tableau, Factory, Clarify, Apache Superset. These are all kind of built on top of the API integrations that we expose. And with JDBC and ODBC drivers that we're enabling with 3.0, this further takes that capability forward. So those, the Power BI, Tableau is already on here, but a lot more tools that folks have wanted to use with Influx that were not possible before are becoming possible. So there's also folks that have built us into kind of the overall architecture. So IO based, which I'll talk about here shortly. PTC ThingWorks, we're the preferred data persistence layer. Ignition, Kenza. So this is far from the complete list, but there's a lot of technology that has Influx sort of underlying. So let's talk a little bit about a customer example here. And this is actually a very interesting one where Terraga Solutions is sort of built something very custom for themselves, Terraga. And they've kind of turned from a customer to a partner. They're the makers of IO Base. And essentially what this is, it's monitoring these different pipelines. They have data that needs to sort of be gathered, but in a very restricted and secure way. So what they've gone from these kind of data historians deployed and creating kind of these silos where the firewall is not allowing access. All right, there's a lot of security constraints that come into play that don't go well with this model. But what they've developed is a patented data diode, which allows for a unidirectional flow of data. And there's in the box right there. We'll see more on the next slide. But this is essentially a full cloud solution. So there's security loves it, developers love it from an agility and development standpoint. In operations, it ticks all the boxes for monitoring, on-call, or reporting. But really, they found that none of the solutions that were available were really what they wanted. So they kind of had to put on the builder hat and build something that now they're able to sell onwards to other folks. So IO-Base, this is the offering that works with in the box, and bottom left here, this is the patented data diode that was mentioned. So this is a sort of hardware level security, allowing data to flow only one way. But IO-Base itself is really something that will work with or without in the box. It's kind of an additional component. But it connects and uses InfluxDB. So any InfluxDB can be open source. It can be our cloud. It can be enterprise on-premise. So that's really the flexibility of having different deployment models. But yeah, IO-Base is really solving that centralized master data problem. There's a minimum on-site infrastructure as they are a cloud-based solution there. It eases the problem of data sharing. There's no hardware or sort of these network considerations to think of, and they have a very high level of cybersecurity. So definitely take a look at this IO-Base. It's a very interesting solution that was developed by Terraga Solutions. An example, slightly anonymized architecture here. This is a FTSE 500 energy company. And you can see what they're doing here is that they have a whole bunch of sensors gathering SCADA data over the OPC UA Modbus protocols. And we have our favorite Telegraph that gathers this data from these places. So Telegraph is basically configured to go retrieve this data, passes it on into Influx, which is then sitting at the edge in all these different sites. So each of these different sites roll and replicate this data to a central Influx server. In this case, it's hosted in AWS. And the overall stack visualized with Grafana is built and extended with the use of web APIs. There's a platform monitoring system that's kind of watching it all. There's a fault management layer, which is using the ServiceNow offering. So you can see these are all pieces that have been put together, given kind of the operational technology side of the house and glued together with Influx data components and kind of the best of breed preferred technologies of this customer. So it makes for a very flexible and maintainable solution here. One more anonymous, slightly aerospace company, so it's slightly different thing, but really at the heart of it, we're still solving a data problem. So we have OPC servers that publish to an MQTT broker. Again, Telegraph comes in, consumes this data, puts it into multiple InfluxDB service servers. So that's one small hidden superpower of Telegraph, is what we call dual write. So you obtain the data from one source, and then you can fan it out to multiple destinations. It could be multiple InfluxDBs. You can even, if you wanted to, put it into like just a raw file, just as like a triplicate copy if you wanted. So again, makes for an extremely flexible building foundation. And yeah, here we have Grafana server to see it all. And there's a kind of a historian as what they've coined this all as. So smart factory IoT use case, even though it's globally distributed, with this architecture, you get that single pane of glass, everything rolled into one. And so wonderful architecture that works very well for this customer. So hopefully that was informative. Just it's super simple. Don't take my word for it. Try it out. You can sign up at influxdata.com. Get your preferred flavor in InfluxDB. We're also available in the marketplaces, so AWS, Google Cloud, or Microsoft Azure. And we are an open source company, so we have to have really good documentation. There's self-service content. We have an InfluxDB University, which can run you and get ramped up very quickly on all things Influx. And of course, power of the community. So we're on Slack. We have a community Slack that you can join. There's also forums. Our documentation is fully open source. University is not, but documentation is. So yeah, there's a lot of great information out there and a lot of folks building with Influx. So hopefully that was useful. And a couple of final resources here. There's another demo that you can take a look at. There's more case studies that we've done, how to save 96% on data storage costs. So 96% is a big number, which is why I kept harping on the why object store is really critical and such a game changer. And yeah, finally, we have a free tier. There's no credit card to put in. You can just kick the tires. It's really cool, and hope you like it. Thank you very much.
Perfect. Thank you very much, Mike, and great timing as well, which leaves us, because we had quite a few questions in, and we now have a good 10-15 minutes to try and answer them. So I hope you're ready to be put on the spot. So first from Brenna Wood, I think she might be asking a little bit much to get an answer in the short time we have available, or a complete answer. But anyway, so for a company who already has a deeply embedded data historian deployed on a large and growing fleet, what are some best practices for getting started on a retrofit and moving to a cloud-based time series data historian?
Yeah, the best recommendation I can give you there is don't try to solve the whole problem at once. Really focus on the problem that's causing the most pain, because it's once you see some little amount of success, that helps to get buy-in from management, from the rest of the organization, from the colleagues, and it really takes a village. So please don't try to solve this yourself, but if you can kind of show somebody a little glimmer of hope, then you can kind of eat the rest of the elephant, if you will.
I think it's a very good life lesson as well, actually. Don't try and do everything at once. Just pick one thing at a time and get that, and then move on to the next one. Fantastic. All right. Manish asks, how do you see the future for InfluxDB? Will you continue to be open source? So now you have to get out your crystal ball, Mike.
Oh, yeah. No, we definitely are committed to being open source. So in fact, our founder and CTO wrote a blog recently about it. So what is the future of open source? Let me just kind of put on my sales hat here for a moment as well.
Yep.
Because we are still a company, and we have, in order for us to continue to serve open source, we also have to have a commercial wing. So that means supporting our existing enterprise customers does still have some priority over it. So we have not given up at all on open source. Open source 3.0 is coming. It's going to be a lighter weight, less feature-rich offering than what is going to be Edge Pro. So yeah, that's kind of what you would expect of, the open source stuff gives you some capability, but then if you want more and the company that's behind it to give you the support, that's where you have to kind of have some kind of a commercial agreement with us. But we're not going to stop being an open source company. I can assure you of that.
Okay, I think that's pretty clear. From Robert Schuster, what are the metrics of massive scale at the database and also the network load?
Yeah, so massive scale, you can look at it in different ways. It can be just overall uniqueness of data. So if you have millions of sensors, each one has 10 tags that it brings with, right? This is going to be cardinality that's in the billions. Even more interesting, we're being challenged by folks that are throwing numbers out in the trillions. So you can think of these as like massive backbones to payment processing. They have really large footprints of systems, and especially when you get into overall traces and events, right? These have completely ephemeral data sets. They're GUIDs effectively. So the more transactions you have, and if you'd like to keep all this forever, that's a very unique data set. So unique data set can equal a very small network payload. And on the inverse, you can have a very small data set, small footprint of, let's call it like a Formula One car. You have sensors that are sampling at 120 hertz, and there's probably thousands of them on there. So you can have very small footprint generating a very large network payload, and vice versa.
Okay. Aaron asks, what is the difference between the clustered and edge single node? Is it just the quantity of devices, or are there any functional differences on premise?
Yeah, that's a great question. So the best way I can differentiate that is clustered is about sustained operations and no single point of failure. So we're talking redundant components, multiple ingesters, queriers, everything, so that you don't have any single point of failure. So critical system operations and the sustained uptime, as opposed to an edge single node, which can have more risk, right? So the risk is mitigated because it's doing a very single purpose task, and maybe that's okay. But a clustered service must be highly available at all times because it's supporting multiple sort of edge nodes underneath it. So yeah, functionally it could be similar. It's really about the sustained uptime, if you will.
Okay. Thank you for that. Let's see, what do we have next? We have Francis. Can it handle large quantity, let's say 4 million data points ingestion?
Yeah, 4 million data points per second, per minute, per day. I guess that would be my first qualifier.
Mm-hmm.
So just the kind of anecdotal data, we've had, and this is a publicly available blog, Hulu from several years ago was able to tune their system to over 1 million metrics per second. And that was accomplished using InfluxDB Enterprise on the 1.x scale. So it would be silly for us to build something completely new that can't outperform the old one. So 4 million data points per second with 3.0 is possible today. It's going to be a more sizable deployment than kind of what you'll find on our website today. What we have published is essentially a medium-sized workload and 3 ingesters, each one with 8 CPU, 32 gigabytes of RAM. That would support kind of this medium-sized scale, as you will, as we define it, and that's probably up to 1 million points a second.
Okay, so I think that's a resounding yes.
Yeah, the ingestion we are very good at, so I can assure you that it tends to be the easier side of the house. It's when the queries, and those can be completely unbounded. They can be, so that it's a very interesting challenge. So it makes my job interesting every day.
Okay, great stuff. Next we have from Manish, does InfluxDB support storage of binary data as well?
Yeah, very good question. So everything that goes into Influx has to effectively be line protocol. So it's that CSV-like format. However, we have some folks that are doing some creative things. So we don't support vector values, but if you can represent a vector value array as a JSON blob, you can store that in Influx. So I myself have tested, you can store more than 2 megabytes within a single field. So that's a lot of data to push depending on the frequency that you're doing it. It's a lot of data to pull back out if you're looking to get a lot of it out. But if you're looking for that single moment in time, it's doable. We have some ambitions of supporting, I completely understand where this binary data is coming from because it's very much in line with the manufacturing space. We hear it a lot. So right now, everything is line protocol, but we do want to develop a new V3 protocol that will be enabling these kind of efficiencies that come with the binary data format.
Okay, perfect. And Francis just has another quick follow-up question on the the ingestion point. How about sub-second ingestions?
Yes, so sub-second, that's fine. We're always assuming there's more than one publisher to the database, so that's where the jitter is very critical. So this way you don't have all of your writers showing up to your door and then trying to dump that payload. You kind of spread them out in between the lulls. So yes, with the Kubernetes architecture, multiple ingestors to spread that load, a networking load balancer to make sure that we're not overburdening any one single node. Effectively, we can scale the system, size it appropriately to handle sub-second. That's no problem.
All right, excellent. So now we have Ala Majup, who's just getting in right at the end with not one, not two, but three questions. So let's see if we can get through all of these. Firstly, is it compatible with OPC UA?
So Telegraph would be the kind of that bridge component, if you will, to make OPC UA connections very simple out of the box. I didn't unfortunately mention earlier client libraries we have available in 14 different languages. Python exceedingly the most popular. So you can think of Telegraph as being one of those methods. But if you are a Python developer and you want to do things with Influx and OPC with using Python, all of that is certainly possible as well. Yes.
All right, great stuff. And second, what is the latency between real-time events and the Influx historian?
I'm not sure exactly how to answer that question. So perhaps I can tell you that data in Influx is queryable immediately once it's accepted. So as soon as that writer gets the acknowledgement of 200 OK, that data can be read immediately from in-memory Apache Arrow. So we have to stay focused on being able to query out that real-time data as soon as it's possible. This is really our key ingredient to being InfluxDB.
Okay. And finally, are the cloud versions compatible with confidential computing technologies like Intel Trusted Execution Environment?
That one I'm not actually familiar with. What I can share with you is those the cloud versions that we manage and operate. They're not in any kind of a gov cloud or more restricted environment. So for that, we would suggest using our enterprise software or clustered, and that you can deploy into any kind of a FedRAMP, GovCloud, air-gapped environment. So there's no real sort of technology requirement beyond having the required kind of a Go runtimes or just kind of the supporting components. So 3.0, there's a lot of moving parts. So as long as those moving parts are there operating at the supported versions, you can effectively deploy this software into any landscape, any environment.
Okay, perfect. I think we just got one more coming in. Ala, again, OPC UA HDA, question mark?
HDA, I'm familiar with OPC DA. That is possible. HDA, I'm going to say 50-50. Most likely it can be that. So yeah, I apologize. I don't know that one offhand.
All right, no problem. All right, so that's the questions. And we are, amazingly enough, exactly on time to finish now. So that's all we've got time for. I'd like to say a big thank you to you, Mike, for your insights, knowledge. We got really quite into the weeds there, I think, and hopefully a lot of people found a lot of value from that. So thank you, Mike. Thank you again to Influx Data for sponsoring the session. Without sponsors like Influx Data, we can't run these events at all. So very, very important. Thanks, of course, to our attendees. Hope you enjoyed it. Hope you found it useful. Thanks for all your great questions. And now it is time to move on to the next session, which is Compliance versus Security, Managing Risk in an Evolving Digital World, sponsored by Fortinet. I'll see you later today for the final session on ICS and OT cybersecurity. Hope you continue to enjoy the event and see you later.